Hi everyone, my name is Rohan Kumar Singh and I am excited to be a contributor to Red Hen Lab as part of Google Summer of Code 2024. My project is called ChattyAI and is guided by my mentors, Professor Mark Turner, Arthur, and Marcelo. This project delves into the fields of construction grammar and FrameNet, providing researchers, educators, and students with a powerful tool for frame analysis. Chatty AI not only enhances our understanding of FrameNet but also allows users to explore frames that are part of UC Berkeley's FrameNet. So, in this project, we will be working with FrameNet dataset and open source LLMs, specifically the Llama models. One of the key components I have developed is a terminal-based user interface called FrameChat, designed to improve the efficiency of the generation process on Case Western Reserve University's. With FrameChat, users can interact with the system in a more structured and accessible way, much like using a chatbot. So this is the GitHub website. First, we will set up a virtual environment for this project and activate it using the source command. Then we will install the required dependencies mentioned in the requirements text file. Afterwards, we will request access to Llama 3 via meta licensing process and clone the repository. Then we will run the download shell file to download the model, ensuring we have the pre-signed URL from the meta. Then we will convert the model to Hugging Face format by running the provided script. Finally, we will run Python scripts like main.py to utilize the model. Next, we will use the FrameNet XML parser. This parser is capable of converting FrameNet's XML files into JSON format by extracting key information such as frame definition, frame elements, and frame relation, while excluding irrelevant data like frame IDs and creation dates. This makes the data more comprehensible and easier to process. I used this script to convert each frame into JSON format and combine them all into a single document for easier management. Now, research papers were also incorporated as a data source for the chatbot. A primary goal was to leverage retrieval augmented generation to enable LLM models to generate results based on FrameNet dataset rather than relying solely on pre-trained knowledge. This approach takes advantage of the rich and growing FrameNet dataset to enhance models' performance while ensuring scalability. To implement RAG, I utilized Llama Index. Llama Index is a framework that integrates large language models with external data sources to deliver more accurate and context-aware responses. It works by indexing data from sources like documents, databases, or APIs into a structured format. The index allows the LLM to retrieve relevant information during the response generation process. In my case, I indexed the JSON files from the FrameNet dataset and used Llama Index to create a query engine enabling the LLM to generate contextually relevant responses based on the indexed data. This is the script I used to initiate basic conversation with Llama 3 model equipped with RAG using Llama Index. Once the FrameNet data is processed and the chat engine is ready, we move to testing. So, yes, I developed the full text annotation parser to handle the transformation of the FrameNet full text annotation corpus from XML to JSON format, simplifying the integration and further processing. This tool breaks down each annotated sentence into multiple layers, including parts of speech, named entity recognition, white space for word sense disambiguation, and FrameNet specific layers. Among these, the FrameNet and NER layers are critical, as they provide essential data for tasks like semantic parsing and linguistic analysis. Next, we created a custom evaluation metric called frame annotation evaluation. to assess the performance of Llama 3 and Llama 3.18 billion instruct models, both in raw settings and with RAG. This evaluation uses examples from UC Berkeley full text annotation dataset stored in bench fn underscore data pickle file. The evaluation process involves randomly selecting an example, annotating it with LLM, comparing the generated annotation with true annotation, and scoring the performance using a custom metric. For each evaluated example, the output includes the prompt generated annotation, true annotation, and calculated performance scores. To accomplish this at your end, you can use these script. And here I have described the evaluation process also in depth. Finally, I developed FrameChat, a terminal-based application for the Case Western Reserve University HPC environment. This application supports users working in construction grammar and FrameNet by allowing them to experiment with frames and explore related queries. After setting up the FrameNet dataset and converting XML files into JSON format, users can run FrameChat on Case Western Reserve University HPC by using these script and also the given key bindings here. FrameChat provides an intuitive interface with key bindings for easy navigation, annotation, and querying of frame details. All of this work is hosted on Case Western Reserve University High Performance Cluster under my user ID RKS110 in the Galena directory. Detailed execution steps are provided in ChattyAI documentation, which I have just shown you. Now let's dive into FrameChat. Now I can show you how it works and how we can run it on Case HPC cluster. Here I have logged in as RKS110, which is my user ID to the Case HPC high performance computer cluster. Now I will be navigating to my work directory available to me in Galena, which also has the same contents available on my GitHub repo under ChattyAI repo name. Now we will be moving to the shell scripts directory. Here, as we can see, there are 4 different types of shell scripts. Each of these shell scripts have different purposes, and their purposes is evident from their name. This is inspired by Cheng, who is also contributing to Red Hen Lab as Google Summer of Code 2024 mentee under the project named FrameBlender. Now we will be executing the request node shell script to request the GPU node for our application. Behind the scene, this script calls config shell file also and activates the virtual environment in advance. The request for GPU node is for 2 GPU 2080 for 2 hours. Now we are currently operating inside a GPU node which have the following files as you can see right now. These files are present in the scratch directory under my same user ID. Now we will use this command python3 cur underscore mnt.py to initiate our FrameChat application. It will take some time to load all the model checkpoints into GPU VRAM. Now our application FrameChat has started and this is the initial screen. After pressing tab, we can start our conversation with this bot. So let us start with a nice small greeting. Here, the frame chat generates a nice reply with what would you like to discuss or learn about today. So why not start with a simple FrameNet question like what are lexical units? So here we can see FrameChat replies with lexical units are words or phrases associated with a particular frame such as frame system in context of FrameNet. Lexical units are the core elements that make up a frame and this and yeah. So basically this is correct. And now let us ask it another a similar question. What is a frame in FrameNet? And see how it responds. And again, FrameChat replies with absolutely correct answer that a frame in FrameNet is a cognitive scene or a conceptual structure that represents a particular situation, event, or state. It is a network of related concept, entities, and relationships that capture the meaning of a lexical unit, such as verb, noun, or adjective. Now let us use our predefined statements like describe a certain frame using its definition and frame name. Now let that frame be attacked and we will see how it responds. So here our frame chat has responded and the frame definition provided is frame attack represents the core action of an aggressive or violent action against someone or something. It involves assailant and the frame elements are assailant, victim, source, also with their frame definition. Depictive, reencoding, result containing event, particular iteration, circumstances, iteration, event, path, frequency, duration, and many more. So now let us involve the attack frame with its frame relation and see how the frame chat responds. So here we can see that it has given us a long answer and we will examine it first of all. Okay, now, yeah. So like we can see here, so we can see here, it did analyze its frame relations with other frames, like the frame attack inherits from the frame intentionally effect and is used by the frame defending. And in addition to this, the frame attack is related to frame hostile encountered through perspectivization, and it has also described the definition of frame hostile encounter as similarly for other related frames. Now let us ask it to annotate our given sentence and see how it performs. So now we have the output and let's just examine it, how it has performed. So yeah, Jones arrived on a Sunday in September. So first of all, this frame is arrival. The lexical token evoking this frame is arrived. It has also identified other frame elements like frame element arrival, the token Jones, and frame element time, which is token on a Sunday. Now let us give it a task to generate some new lexical units for the frame attack. It has generated some new lexical units such as ambushed, raided, assailed, beset, encircled with their own definitions, and this is quite correct. Now let us give it a task to create a new frame with no additional details. Now we can see without much information it has created a new frame called travel 8. We can see travel 8 as a specific category of travel related activities. The name travel 8 was chosen as part of its versioning system and can be used to make new frames with new versions. So let us give it a more detail like please create a new FrameNet frame related to celebration with its possible frame definition, frame element, and lexical units. So here we can see it has generated a new frame called celebration, which is also not present in the UC Berkeley's FrameNet dataset. And if we go through the frame definition, a celebration is an event or activity that marks a significant occasion or achievement, often involving joy. And it has also listed frame elements, entity, occasion, activity, location, time, manner, role, instrument, and also its lexical units like celebrate, party, festival, commemorate, rejoice, ceremony, parade, feast, which to me is absolutely correct. So I have also incorporated a unique feature which will be useful to many students and researchers around the globe, which is toggling between short context mode and long context mode. Currently, all this conversation is occurring in short context mode, which means that the model only has the memory of the current given input, not of any previous inputs. But if we toggle that to long context, that it will have the context of previous two conversation messages also. So let us try that. So why not ask it to differentiate the travelate frame generated a real and the general travel frame. So here we can see it has given the main differences between the two frames, which is the original travel frame has a more general definition, focusing on the concept of moving from one place to another. In contrast, travel 8 frame that I generated, where I represent frame chat, has a more specific definition emphasizing the aspects of traveling, such as mode of transportation, accommodation, and activities, and other differences are also mentioned. So this highlights that the model is also able to retain the context of previous two messages and also answer logically. So by the time I completed this project, Llama 3.2 had already been released, offering even more powerful models than Llama 3.1 version I used. A more advanced model naturally brings enhanced core capabilities. FrameChat can also be treated as multilingual, supporting languages available in Llama 3.1 model, which we used, with the potential for expanding to more languages. Additionally, we can further train the models to improve their performance. I would like to express my sincere gratitude to my mentors, Professor Mark Turner, Arthur, and Marcelo, for their continuous guidance and support throughout this project. They have been instrumental in connecting me with other contributors from Red Hen Lab, such as Cheng, and with the technical support team at Case HPC platform. My time at Red Hen Labs has been incredibly productive and rewarding, helping me refine my programming skills and meet many talented individuals. I believe this mentorship has been crucial in fostering strong connections and facilitating knowledge transfer within the Red Hen Lab community. I look forward to continuing many contributions to these open source projects and maintaining lasting relations within the Red Hen community. Thank you.